So this there is a very famous quote from Ellen Perlis, and this is from the very beginning of the software development around 60s. This quote is from his talk. He says that a software system can best be designed if the testing is interlaced with the design instead of being used after the design. So it is not a new idea; it was there from the very beginning, and I really advocate that writing unit test as part of your development process, and it really helps. Okay, let's understand why it is important. So who am I? I am a Go developer, and I have been programming in Go from past 4 years. In fact, I started my career uh, with the project which is written in Go, and I have been part of the community software projects in JFrog lately. But recently, I joined X-Ray team, and I'm contributing there. Apart from that, I am an open source contributor. I have made contributions to many open source projects like Kubernetes CSI, Longhorn, Ceph, etc. And I'm a part-time writer. I share my learnings in a blog on Medium, and I am an early morning person. Okay, let's get started. So this is the same slide that Ari has shared. You could probably scan this QR code and win swags. All right. So these are some of the top topics that we are going to cover. Unit test, what, when, and why. Unit testing workflows like table-driven testing, behavior-driven testing, unit testing techniques, and there will be a short demo, and after that there will be a summary what we have learned so far, and then there will be a Q&A session. Okay, so uh, when I started my career back in my previous company, so everything was tightly coupled with the Kubernetes ecosystem and containers. So you guys probably heard of project OpenEBS, which provides containerized storage for the containers. So one of the main difficulty was whenever we are making any changes which is logical, we need to deploy a Kubernetes cluster and build an image and push it to the Docker, and then deploy our changes to the Kubernetes cluster and then test our changes. So this process is really very cumbersome, and which was making our development cycle very slow. So uh, what we have decided that we will make our code very abstract, and we will write unit test and improve the test coverage so that we can test our changes quickly, uh, whether it is logical or it is anything, so that we don't have to deploy at any time and go to the Kubernetes cluster and test everything, and we can logically we can test our changes immediately by writing unit test cases and modifying. So during that day I realized how important unit testing is for any project, and I really advocate to everyone to start unit testing as soon as possible, because it really reduces the chance of making mistakes in your project. Okay, so what is the unit? If you ask this question to people, they will probably say unit could be a method, a class, okay, a package, anything they will name as unit. But in Go, you design your test case keeping package in a mind as a unit. So in a Go, a package is known as a unit, so you have to design your test cases accordingly. So this is just a basic definition of unit testing. It is a way of testing where you mainly focus on the behavior of your unit rather than you go deep and spawn some of the environments and then test your changes. So it basically means that you have to test the behavior. You will provide some input, and then you will expect some output that is matching your behavior or not that you had expected. Okay, what unit tests are not? So this is a tweet by Dave Chaney. So he writes that it takes, if it talks to the database, if you are communicating to a database in your unit, then it is a not a unit test case. Okay, if it is communicating across the network, it is calling some REST APIs, then it is not a unit test. If it is creating reading from file system, then it is also not a unit test. It cannot, means at the same time you cannot run multiple test cases, then it is also not a unit test case. So what we have to do, we have to remove all the third party dependencies or any kind of dependencies that is required to run your unit test. You should only focus on your business logic, not on the other logics. Okay, you should only focus on your business logic, not on the environment. So we will learn about this, how we can do. Okay, 5 unit tests in Go. It really helps in verifying small changes, especially refactoring and debugging. Suppose you are just now make any changes recently and you want to validate it. So what the usual process is, you will build your binary, push it to the your pipeline, and then you'll see the logs and verify whether you have written correct or not. But it will take some time. You will make some changes, deploy to pipeline will take its own time. But to verify the same changes immediately, it will be better to write a unit test and then make some changes, do refactoring, and then validate whether it is working or not. Let's quickly go through an example and we'll come back to this slide again. So there is this function, small change. It is taking two parameters, small and change, which is string, and then it is basically adding those two strings and returning it. So if you see this function, it's not a very big. You can easily, means there is a very probability is very less that you can make any kind of mistakes here. But what about this case? This function is taking 25 basically here in this constant parameter that you see, insert pull request statement, here it is taking 25 arguments. So chances of making mistakes is high here. You could replace, means there could be some string data type, there could be some integers. You could change its place. There is a possibility that you might do that because there are 25 parameters and you might make some mistakes. So unit testing helps in such scenarios, and you can verify your changes quickly, that you have not made any logical errors. In such case, you can rectify it and immediately fix that. Okay, let's go back to the previous slide. Measures the quality of the code. So how do you measure the quality of the code? There are various parameters like cyclomatic complexity, okay, and whether your test is reusable or not, whether you can abstract your code or not. So that's how you measure the quality of the code. So if you think that your code quality is not good, only because you have not written unit test cases, and writing unit test case really eliminates those it really eliminates whatever be the issues with their code, like if it is not if it is having a lot of cyclomatic complexity, or it is depending on some of the third party dependencies. You can eliminate that using while writing your unit test cases. Okay, it helps in understanding the complex logics. So recently I have been to this part of X-ray team, and it has around 400k lines of code. So if I would start from the main function, and then it will take me almost 6 months minimum to understand entire project, or maybe more than that. I cannot cover everything. So I cannot really start with the main and then learn about a project and then I will start contributing to it. So if there would have been some unit tests and it is there, so I can quickly pick up some of the part of the code and read it and make some modification, learn the complex logics inside the unit, and learn about a whole project and immediately start working on some bug fixes or features. So it really helps there in understanding the complex logic, helps in understanding cause of failure quickly. So as I said earlier, if you will if you will do some kind of bug fixes, or you will refactor your code, and there is chance of failure, you can only get it while running your binary in a pipeline or locally. You cannot you cannot know the cause of failure immediately. If if you write unit test cases, you will get to know it very early. Helps reviewer to understand the fixes and changes. So reviewer can also go through your test cases, and if there are any kind of bug fixes that you have done, he can quickly go through your test cases and find out, okay, you have covered all the edge cases, and he can understand your code as well by pulling your changes, and you can modify and understand that. It is a great way to learn about a language as well as project. So if you are new to a language, it will really help you, because you will get to learn a lot of new stuff inside a unit that has been used, and as a project, as I told earlier. Okay, so when do you unit test? I will cover this at the end of the talk. Okay, moving on. So there are various testing workflows like table-based testing, table-driven testing, and behavior-driven testing. So both of these methodologies are widely used in the industry and in various projects. So far, what I have seen that people usually use table-driven testing for writing unit test cases, and behavior-driven test cases for basically for functional test or integration test. They use behavior-driven testing. They use some tools like Gingo, which is written in Go, or Groovy. So we at JFrog also use table-based testing for unit test, and we use behavior-driven testing approach in functional testing and integration testing. So if you follow Kubernetes project, you can also see that they are also using the same pattern. They say it end-to-end testing, and it's written in Gingo. They are using Gingo framework. So in table-based test, there is a map and slice used to build the input and expected outputs. Okay, and basically what you do, you create a map of inputs and then expected output. Then you run your unit test cases uh, based on those inputs and expect outputs. It is easy to implement and easy to extend further as well, because what you have to do, if you find some edge cases, you can quickly add a case and then extend it further and verify your changes. It gives a clear visualization of what's covered and what not. So let's say you are covering you are writing some of the unit test, and you are adding some of the unit test cases, and you want to see whether you are covering or covering the part of your logic or not. So using unit test, there is a flag called hyphen cover. So while running your unit test, you can just add that flag, and it will show you what has been covered and what not. Behavior driven testing. So it is like it's usually the main purpose of behavior driven testing to make it any layman can understand by reading the description of the code. He don't need to understand the syntax of the code. He can, it's written in such a way that anybody can go through the source code, and he can see that it's very much readable, and it's helpful in let's say there are many stakeholders in the company, and they want to see whether what has been covered and what not. So in that case also, behavior driven testing works. They can easily read the description and understand, okay, this functionality has been covered. It requires planning and a lot of effort, because you need to plan out what all our features that has been given from the stakeholders, and then you will have to learn the syntax as well, because every behavior driven testing framework has its own advantages and disadvantages, and you will have to learn the syntax. So it's also helpful in understanding the functionality of a project, because once you have covered all the functional tests, anybody can go through it and understand what all the features that it is covering, especially to the stakeholders. Learning curve is little high because you have to learn the syntax. Okay, and Gingo and Gomega framework is preferred by various projects. That is very widely used, and people Gingo is a basically BDD library, and Gomega is a matcher library that is used by people. So let's let's guide you. Let me show you some example how it looks like. So there is this function called a sum, which is taking two inputs, and this is the main function from where I'm calling. And let me share that how would BDD testing will look like. So this is the main function where I'm calling this sum, and here we have main test.go. So describe. So this is a sum function that I'm testing. I'm describing about it, and there is a before each where you initialize your variable, and then context where you add some some specification about the test, like what you are going to do, and then expected output. So you can clearly read it like by providing two digits at input, it should return some of the two digits, and then there is some expected input and outputs. So let's run it quickly. Here you can easily understand that sum, by providing two digits and input, it should return the sum of the two digits. So it's clearly any layman can understand this, what these tests are doing. But uh, if you run only go test, it is blank, right? It is blank, it is not giving you idea what it is doing. Means unless otherwise there is some programmer who has written this test case, or who knows go, they can only understand this. Otherwise this no layman can understand of what is written in the tests if it is written in plain unit testing and go. But using BDD framework, it is very easy to explain it to others. Okay, now coming back to the slide. So this is the same that I have showed now. Okay, now coming to unit testing techniques. So there are various unit testing techniques like subtests and parallel tests. So in subtest, basically there is a one test, then there are multiple tests under that particular test. Then there is a parallel test where you can run test parallelly, each of these tests parallelly. And then mocking, we'll learn about mocking as well. And there is a fuzzing. So fuzzing, I will explain it later, but I will not cover fuzzing since due to the kind of time constraint. So let's quickly jump to the subtest and parallel test. So if you see this code, test sequences, so there are three subtests: some test, some, sorry, there are three test cases: some test, some other test, and some any other test. And just for representation purpose, I am not calling any function, I'm just doing time dot sleep. So if you run this test sequential test, it will run sequentially and it will take 3 seconds to finish. T dot run, first some test will run, then some other test, then some any other test. Whereas if you see the parallel example test.go, I am calling t dot parallel. So what it does, it spawns each of these run closures in a separate go routine and runs this parallelly. So it will not take 3 seconds, rather it will take 1 second based on the availability of the CPU. Okay, mocking technique. So mocking technique is very debatable because people usually sometimes recommend, sometimes don't recommend, because it adds a maintenance cost to the project. That's why sometimes people avoid mocking, and they avoid unit testing as well due to the same reason. And if there is a lot of if the project has not been planned very well from the beginning, then it is very difficult for people to start writing unit test cases if projects is increasing day by day. So let's learn about this mocking. There are various mocking techniques that I use and people use it. So the main purpose of mocking is to basically isolate all the extra dependencies, that the third party dependency that you are having, and mainly focusing on what is the behavior of your code, or what is your behavior of your business logic. Okay, it will not depend on any kind of third party libraries, or let's say any kind of database or system calls, whatever you are doing in your code. So you have to mock those and test your business logic. So it is a one-time effort, but really helps in verifying your logic quickly. So there are various ways to mock. There is a tool as well, mockgen, which generate mocks for your code. So I will show you shortly. Okay, so one is this there is a this quote in Golang which is very famous: accept interfaces and return struct. So let me show you the example. All right. So this is the sample app where I'm spawning a database. Uh, there is a database dot setup, and this is calling new user, and then inserting it. So if you see this insert user function that I'm calling, this we cannot unit test this. If means for unit testing this one, I need to start a database, right? Database instance. But there is a technique. The technique is I'm creating an interface, and there is a user structure that is implementing that interface. Okay, insert function. So what I will do while unit testing, I have to test my logic. Let's say here I have not written many logic, but let us something like, if there is some logic, if id equal to something, okay, if id equal to 1. So my focus when I'm writing unit test, my focus will be testing only if id equal to 1, or any or if there is any other kind of business logic that I have written. My focus will be to cover that case, not calling database and testing that. So what I'm doing here, I'm calling new user. Okay, so here I'm returning structure and accepting users is a interface. So the what will the benefit of this one? So benefit of this one will be, whenever I am testing insert user, I will pass the mock object of the user instance, and whenever mock instance of the users, and this insert will be called, this will not be the calling the database insert, rather it will be calling the mock objects insert method. So let's quickly go through the test. So I have given actually two examples. There is one that I have generated a mock, and here I have implemented the mock. There is a mock struct that is implementing user interface. Uh, there was only one insert function, so I'm using that. So there, if you see, there are two test cases. One is test user and test user insert user two. So here I'm using a library called gomock.new controller. So I will show you shortly. So if you see this mock database, there is a user mock.go. So this file has been generated from a tool called mockgen. Okay, so there is a tool called mockgen, and here I can call this from previous package. Yeah. So this is my file, and there is a user interface, and let's say I want to generate mock for user. So there is a mockgen tool. Mockgen, and dot means current directory, and then users interface. So what it will do, it will generate a mock for me. So if you see, this is a mock database package, and it has generated this mock user structure, and this insert function, that is the implementation of and that is the implementation of the insert function, which is a mock one, and I will be calling the same insert while testing that. So let's test this. Okay, so let's go to the test again and explain you what is happening. So in test insert user, I am calling, I'm passing my mock user. Okay, that the mock implementation of user that I have created. And in insert 2, there is a go mock dot new controller that I'm calling. This is the library that you can use. And here, uh, when it will call the insert function, it will basically call mock use this mock database, uh, mock database insert implementation. And here is the return parameter that I want in the return, like 0. And in this case I want error, because in the previous case I had test the positive test case, and here I want to do the negative testing. And here I'm providing times 1, means it will run only 1. If you again call this insert user, it will return an error. So this is one way of unit testing, means implementing mocks. Now let's go to the another techniques. So there is this complex function, and it is basically accepting a struct, and it is calling get from db publish. Okay, and then at the end it is calling some notify service. So this code is just for representation purpose. I just my purpose is to explain you what is the problem with this code. So if you see, there's dependency on get from db, which is the external dependency on database. And then this is let's say it's using some kind of messaging queue like pubsub. So it is calling publish function, which will again call to the Google Cloud, basically pubsub instance of GCP. And then it will verify the this logic. So my primary purpose is to test this logic ss dot field equal to 1, not this one. So I cannot unit this complex, right? So what we can do here to simplify this? So what I have done, I have created 3 functions: get db func, notify func, and public func. And I am passing this to simplify. Okay, get, notify, and pub. So what I will do, whenever I will write unit test case, I will provide the implementation of get, basically mock implementation of get, notify, and publish. Okay, and what it will do, it will give the expected output that I'm expecting. I will return from the functions in the implementation, and then I will verify these logics. Okay, so this way I can test it. But still there is some problem with this one. The problem is, let's say this library or this function that you have used is used by some other packages or by some other people in their different projects. So if you modify this function, this will be a breaking change. People cannot use your function and update their libraries, that latest change that you have done. Okay, so this is the problem with this approach, because you have to change the function signature. So is there a better way? Yes. So what we can do, we can so this is the test case that we are, so in the simplify that I explained now, this is the test case for this one. I created the function get, publish, and notify, and then I'm passing to simplify while testing it. So this is how I explained a few minutes earlier. And there is a better way to do the same thing, that is just do a implementation of simplify in a just wrap in a structure, and put this notify, publish, and publish to uh, as a part of the structure. And while testing this, okay, while testing this, you can do something like this. You can create an instance of some struct. You can create a function, disclosure, get, pub, notify. It's the same stuff that we have done earlier, but now this time I am putting this in a structure. And then we are calling better dot simplify, which is testing this function. This way we can avoid we cannot basically we can avoid any kind of signature changes, function signature changes, and it will not break the library. So you can still have the same changes, but it will not break it. Okay, now coming to fudging techniques. So it is a testing technique where you provide some kind of invalid or unexpected any kind of data to your functions and see how it is behaving, right? So in some cases what you will see that it is crashing, it is creating some kind of noise in your setup. So this really helps in testing and in determining if there is any kind of memory leaks or crashes, so you can get to know about your code and do any kind of chaos testing using fuzzing techniques. So it really helps uh, in such scenarios, because if it will go into the user's environment and they will do their testing and they find out that, they will complain you, right? So it's better to do fudging techniques by your own and test the behavior. I think okay. So why the fudge? So recently I was working on a project and it was downloading some kind of file and then parsing it, and then it is calling some function that is basically parsing that file, and it is storing in a map of interface. So the problem was, uh, later I made another implementation. Instead of downloading a library, downloading that file, I was passing the exact structure that I needed. So what was happening, there was no check. Like in this case, I'm creating a variable of interface and this is a string basically. So if I will do I dot string, it will pass, but if I will do I dot float, it will fail because it is not float type. Okay, so this is how they have ignored in the function. They were directly parsing into the string because earlier it was being downloaded, so they know that the type will be string. But later when this was coming as a REST API in the later implementation, this change was broken because it was not coming as a string, and this check was not there, it was coming as null. So that it started panicking and the functionality was not working. So this is why we need first testing, so that we can provide invalid inputs, so that it will break and you will know the change before pushing it to the customer. So there are libraries that you can use. Sorry, I think it's my slide is not moving. Okay. So there are actually some libraries like Google Go Fudge, which is a first testing framework for Go. So it is helpful because you might miss some complex edge cases that I explained of what happened with me. And if you add first testing to your code, it really improves the quality of your software. I think there is a problem. It is not moving to the next slide. So I will share from this screen only. Okay. So now coming to when we should unit test our code. So we should always write your unit test for our code. Sometimes time doesn't permit, or your manager won't allow writing unit tests because of the clear timeline, that strict timeline, and you cannot write unit test because you are mainly focusing on deliveries, right? But you should always try to write the unit test case for your tools. It really improves the quality of the software. There will be less chances that you are going to make any mistakes. And if you think it's really easing your job, for me in my previous company, it really in this company as well, I'm finding it very helpful. If there are any unit tests written, I'm able to easily understand and make any kind of changes or fixes right away. Otherwise I would have to go through the entire test code. I have to start debugger, understand the code flow, then I would be able to know and start working on a project for any kind of changes or fixes. Also, if you do not have, because when you start project you do not have integration test coverage, right? So Writing unit test case will give you some kind of confidence, while it will give you some kind of confidence so that you can release your product, right? When unit testing will be in place, it will help you in verifying whether everything is logically working or not. Also, if business logic depends on the third party components, writing mock is one time effort, but it is very helpful. Also, earlier it was very difficult in Go to, basically you will have to write it manually, but recently, just couple of years back, there was a tool mockzen that has been in the community from a while, and people use it. It really helps in generating the mocks and making your job a little easier. Okay, so what we have learned so far: testing behavior, not the implementation. We have to test just our business logic, not we do not have to test how database is working. We have to test how our logic is working. Make everything configurable by inheriting them in instruct. Avoid global variables, because if your code is written for any concurrent use, then there might be possibility that same go routine is accessing global variables, right? So there is a chance that you may miss, and there is you accidentally add races to your code. Use interfaces if there are third party dependencies, okay? Because it will be helpful in mocking. Okay, closures helps you a lot in extending your code further. So as I shown you earlier, so there was a get db call, and then publish a call which was calling to pubsub api, then there is a call to notify. So these are all third party dependencies. So if you really have to, so the benefit of this one, today you are depending on a pubsub. Later, if the need arises that you want to switch to RabbitMQ or Apache Kafka, it will be very easy for you, because you will have to just give the different implementation of the same function, uh, right? Earlier you were using PubSub, now you, in some other use case, you are using Apache Kafka or RabbitMQ. You just have to change the definition. Your business logic will remain at the same place. It will not going to change. Accept interfaces and returns, as I told you, it really helps you in mocking. Avoid mocking networking, instead of make helper functions to test the functionality. Let's say you are uh, spawning up a server to test your some of the changes like REST API and all. Instead of that, you just create some kind of mock functions that will do the job for you. It will create some fake response or fake request for you, instead of spawning a whole server, right? It is not only resource intensive, also it is little bit hard, okay, in doing testing. Although Go itself provides some test server, which is really helpful in such cases, but I would say mocking is a good idea than creating your own server or starting a server. All right, so these are some references that I took help, uh, and there are some more links. This is the link to my blog that I have written. If you want to learn about Gingo and getting started with it, you can follow these logs. There are 3 parts. And then there are few quotes. Testing is hard only if your code is not organized well. And writing unit test really helps in organizing your code. It improves the quality of your code. And these are guidelines, not rules. Any questions?
Awesome. Thank you so much, Akash. That was a great talk. So we have some question coming in from
Thank you.
our YouTube. Let me just pull them up. So first question from Sirin. What are your what are your techniques to avoid fragile tests? Uh, an example is a change causes a large number of tests to fail.
Yes, so actually there is no such techniques to avoid fragile test. It really depends how you have written your business logic, or especially it depends on your implementation of your methods. So if you are changing your behavior rapidly, right, just follow the approach that I have shown you. If just use closures approach so that you can change the implementation on the fly when you are going to test. And if there is some behavior that is changing rapidly, like I gave you example, like if you are using PubSub today and tomorrow you want to make use of RabbitMQ, so what you have to do, you just have to uh, change the definition, right? Change this implementation of that function, so it will not break. Later you can anyhow switch that. Today you are using PubSub, tomorrow you can easily switch to that, because your business logic will always remain same. It will not going to change. Infra will change, but your business logic won't change, right? So that's how you can avoid uh, fragile test cases or writing fragile tests.
So it's like modularizing your code so that you have clear boundaries, right?
Yep.
Cool, awesome. We have another question from Sirin. At what point is it worth investing learning time to learn tools like MockGen?
Okay, so it's very easy, actually. In fact, I thought it is very hard, but today morning I just did some experiments, and it's straightforward. There is just simple command using go generate, means maybe probably in few weeks or in next week or by this weekend I will probably write a blog about it and post it there. It's very easy. Just you can go through the documentation of MockGen and you will find it's very easy.
Awesome.
It really reduces your effort of implementing your mocks by your own, right?
Yeah, please drop the blog link into our event comments if
Yeah,
if you
sure.
wanna write it. Cool. Another question from Mas Aji. How to test if there are any dependencies on the function inside my function?
Yeah, so this is boiling down to the same approach. So there is this slide. Are you still sharing my slide?
Yep.
Yeah. So here, if you see, this is a very you can say it is tightly depending on the database, get from DB and then publish, right? It is very difficult in this case to test this function. You cannot test this complex function without somehow eliminating the dependency from database or publish, right? So the technique is to use same either closest approach or using interfaces approach. Just accept interfaces and return structs. That will help in modelizing your code and making it testable.